I have up here on the board three really long words. One is the antiderivative. This is the process that we're going through here to compute an antiderivative, or this is what we're trying to achieve, the antiderivative. The process is called antidifferentiation. And then if that process is possible, then when we say a function has antidifferentiability, none of these words you need to have written out, and I'm not going to ask you to define them. But the point is, this was originally done in Latin, and there are enough syllables here to satisfy anybody, I would think. There is other language, other terminology that we use, and it's a little bit more user-friendly, and certainly is less polysyllabic. And so, what we can write is this. If f of f is the function, then this is the symbol. This symbol, I'm going to make a little bit better one here. It is an elongated S, similar to the elongated S's you might see if you saw a handwritten script of the Declaration of Independence, for example. In that time, the typesetting was these S's were elongated. The reason this is an S, as we're going to see later on, it stands for the word sum. And it's not obvious that this stands for something having to do with the word sum, but that's where this symbol comes from. It is the S that's been stretched out and elongated. And we call this process integration. We use integration to find the integral. And if this process is possible, then we say it is integrable. Instead of antiderivative, it's an integral. Instead of antidifferentiation, it's integration. Instead of blah, 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 it's integrable. And so we typically use this language rather than this, although, strictly speaking, they are interchangeable. There are times when it's actually more illustrative and more convenient to use this language. When it happens, we'll use this language. But typically, we'll use the language of the integral. And so now we're talking about integrals. There are two main branches of the calculus. One is called differential calculus. That's when you're computing the derivative. And the other is integral calculus. That's when you're doing the antiderivative. So this is standard. This is the standard symbol. This symbol is called the integral. The function is called the integrand. This is called the differential. All right? And this next piece, this little piece I'm going to write in green, this is not official, but this is a really good way to think of it. This is the variable indicator. All right? Here's where that comes into play. Remember when we did this just a couple videos ago? If this is given to be f prime, and we want to work our way back up the hill to find function f, we use the power rule, but we have to use it backward, right? So our power rule says you add 1 to the exponent, and then take 4 and divide it by the exponent you just created. Right? So 4 divided by 2 is 2. And now, we also need to add, remember, our constant of integration. This is called the constant of integration. All right? We're going to talk a lot about that later on, but that's called the, pretend you can read my handwriting. It's called the constant of integration. Now, here's where this variable indicator comes into play. All right? We recall that if you're given G as 4x, then we know g prime is 4. The derivative of a linear term is 4, right? This is the derivative process. But suppose we were given g prime of x is, oh, let's say 7, a constant, and we want to work our way back up the trail to see what is the antiderivative. What function would that have come from in this differentiation process? Well, our rule was for a constant function, you reattach the variable. The question is, which variable? That's one of the purposes of that symbol. It tells you which variable to reattach. The antiderivative of 7, in this case, is 7x plus our little constant. All right? But watch. Suppose I have h prime of t is equal to 8. And we want to find the function that came from. What I'm going to put here in the red is wrong. This is wrong. Do you see the wrong? I've reattached the wrong variable. The antiderivative of 8, if this is h prime of t is 8, the antiderivative of that function, this is a constant function, the antiderivative of this function is not 8x. What is the antiderivative? Is it clear? The antiderivative here is 8t plus the constant of integration. That's the value of h of t. And so this variable is required. It does other things as well, but at the very least, it indicates which variable to reattach. Well, that's what this is all about. This tells us which variable to reattach. Because this function inside might be a constant. This tells you the variable to be reattached. More on that in a bit, but for now, one way to think of it is this way. This symbol, the integral symbol, and this symbol, the differential, are like bookends. They're like 4 times x plus 7. If you're going to use the distributive property and you were given this problem, what is your appropriate reaction? The appropriate reaction is, this has a typo. This is not a complete problem. If you open parenthesis, you must close it. If you open an integral, you must close it. If you have this symbol, the integral symbol, without a differential, no matter what else happens, no matter what else is going on, if you have the open without the close, it's wrong. There's no way to fix it. Because if we have the antiderivative of, let's say, 4x, well, we might think we can do this antiderivative here, right? Let's play this game. So this is correctly written. Let's actually find the antiderivative. Let's apply the process. Take the integral of 4x, and really the way you read this is with respect to x, using x as the variable. Take the integral of 4x using x as the variable. Well, what do? You add 1 to the exponent, divide by the exponent you just created, and then add the constant of integration, and that's correct. But watch this. Suppose I have the integral of 4 using x as the variable. The question is, what is the integral, what's the antiderivative of a constant? The antiderivative or the integral of a constant, the integral of a constant, is you reattach the variable. But here comes the rub. Watch this. The integral of 4 dt. Maybe we're working in physics and the variable is not x, the variable is time. So now we're working with 4 dt. Now the question is, what is the antiderivative of 4 using t as the variable? Watch, if a student says this is equal to 4x plus c. That's the same error as happened over here. You're attaching the wrong variable. This is not correct. This is false. This is not correct. It's bad enough when we do it poorly here in Calculus 1. This is wrong. This is not correct. Students think they have the basic idea. Yes, you have the basic idea, but it's still not correct. It's going to get even worse when you're working in Calculus 3, and in one problem you will have the variable x and the variable y and the variable z, and you do the antiderivative with respect to x is not the same thing as with respect to y, and neither of those is the same as with respect to z. When you start to increase this complexity, you really get into hot water. So, I'm going to be the notation police this semester. This equal to this is nothing. This is false. You get no credit. This is wrong. I'm wrong, wrong, wrong. No partial credit. This is not right. Okay? What should it be? What should the correct result be? The correct result is you reattach the variable. The variable in this case is t. This is correct. So, among other things, there are other things in play as well, but among other things, this is the variable indicator. And, among other things, this is a false statement, because that and that are not equal, because this has no meaning. If you open without a close, it's crap, just like if you open without a close here, it has no meaning. So, integral sign, integrand, the function whose integral we are computing is called the integrand, and the differential. The differential, among other things, is the variable indicator. There actually is much more information here than at first blush you might think. Integral sign, integrand, differential, this is the variable indicator. You never have an open without a close. This has no meaning mathematically. This is correct.